Synthesizing of nanoparticles using solution combustion method. Hello everyone, today I am going to present the calculations and experimental part of solution combustion method used to synthesize aluminium oxide nanoparticles. This video will clear all your doubts related to solution combustion method as I explained the most essential calculation part and experimental part very clearly that you do not get in any other videos. So watch till the end. Solution combustion method to synthesize alumina powders. Solution combustion synthesis is a quick and easy process to synthesize nanoparticles with an advantage of saving of time and energy. This process is used directly in the production of high purity homogeneous ceramic oxide powders. This method is versatile for the synthesis of a wide size range of particles, including nanometer size alumina powders. Now, in this video, I am going to synthesize the aluminium nanoparticles. So, the chemicals used here are aluminium nitrate, sugar, and deionized water. And here, to prepare this aluminium nitrate nanoparticles, we are using apparatus like weighing machine. So weighing machine is used to measure the weight of the chemicals. Beaker is used to prepare the solutions. Magnetic stirrer is used to mix the solutions of oxidizer and fuel properly, as manual mixing may not be sufficient to mix the solutions. Furnace to heat the solutions, and crucible is used for calcinations. Now here the materials that we use is, here you can see aluminium nitrate. So this is the aluminium nitrate metal salt we are using. So that is represented by AlNO32. So that is aluminium nitrate monohydrate, and this formula is written on the bottle itself, and the molecular weight of this aluminium nitrate is also written on the bottle. So that is 375.13 grams. Aluminium nitrate is taken as oxidizer. It is the raw material for the final desired product, that is aluminium oxide nanoparticles. If we are using zinc, if we are in requirement of zinc nanoparticles, then we will be using zinc nitrate as the oxidizer. Here I am synthesizing the aluminium nanoparticles, so I am using aluminium nitrate as the oxidizer. It is the raw material for the final desired product, that is aluminium oxide nanoparticles. In this experiment, I used sugar as a fuel. So here you can observe sugar, that is the daily table sugar that we use at home, that is taken as fuel. The organic fuel acts as a reducing agent. Here fuel, so that is the common sugar, common name we call it as the sugar or the sucrose, and its chemical formula is C12H22O11. Its molecular mass is 342.30 grams per mole. Here the main reason why we use fuel are they are the source of heat. So when this fuel are mixed with the oxidizer, they increase the combustion process. They are the source of carbon and hydrogen, and during the combustion process they form carbon dioxide and water. They form complexes with the metal ions and facilitate homogeneous mixing of the cations in the solution. And so this fuel is used, and apart from this fuel, so here I am using the metal nitrate, that is aluminium nitrate, and sulfates also we can use. And fuels can be any carbohydrates such as the sugar or glucose or sucrose or urea can be used. Urea or glycine can be used, as these carbohydrates contains, as the organic materials contains carbon and hydrogen. And before we proceed with the experimental part, first we should know what quantity of chemicals should be used. For that we need to know about the calculation part. And before we proceed on to the calculation part, we should know what is the oxidizer to fuel ratio. So this oxidizer to fuel ratio is gives the information about what type of the uh, oxidizer or fuel we are taking. That depends on the combustion temperature, the fuel to oxidizer ratio, and the amount of water can affect the reaction and the products of solution combustion method. In general, a good fuel should not react as explosives and make toxic gases. So, the fuel that we consider for this reaction should be taken very carefully. And if the oxidizer fuel ratio is equal to 1, so that we call it as the stoichiometric ratio, that means the initial mixture does not require any atmospheric oxygen for a complete oxidation of the fuels. And if the oxidizer to fuel ratio is greater than 1, then we say fuel is less and the oxidizer content is more. And if the oxidizer to fuel ratio is less than 1, then we say fuel rich. So that is fuel is more and the oxidizer is taken less in quantity. So now here, the to calculate what quantity of the metal nitrate should be taken, we use a formula, that is weight of fuel divided by molecular weight of the fuel into valency of fuel is equals to weight of metal nitrate divided by molecular weight of metal nitrate into valency of metal nitrate. Now this we can just write it as weight of fuel is equals to weight of the oxidizer into molecular weight of the fuel into valency of oxidizer divided by molecular weight of the oxidizer into valency of the fuel. Here in this video I'm using aluminum nitrate, so here I'm doing the calculations for aluminum nitrate and the fuel sugar. You can use the other salts, that is the metal nitrates you can use to form, so that is the zinc nitrate can be used to produce zinc nanoparticles, or lead nitrate can be used to synthesize the nanoparticles. And the fuels that we are using here in this experiment, I have used sugar, or apart from sugar you can use urea or glycine, or if we are doing the green synthesis method, in place of that sugar or the glycine or urea, you can use even aloe vera gel also, aloe vera gel or lemon, so any plant product so that contains the carbohydrates, carbon and hydrogen, can be used in this for the solution combustion method. So now valency of the oxidizer we are going to calculate here, aluminum nitrate. So in this video, if you observe, the valency of aluminum is +3 and valency of nitrogen is taken as 0, oxygen is -2, and the whole thing is multiplied by 2. So 3 plus 0 in plus 3 into -2 into 2. So the total we get valency of the oxidizer as -9. And now this -9 we are not directly using, we are just neglecting the sign, minus sign, and we use the valency of oxidizer as 9. And here the valency of the fuel, that is sugar, is calculated. Sugar chemical formula is C12H22O11, carbon valency is 4, hydrogen valency is +1, oxygen valency is -2. So if we calculate 12 into 4, 12 molecules of carbon into 4, its valency is 48, 22 molecules of hydrogen into its valency 1 is +22, and 11 moles of molecules of oxygen multiplied by its valency -2 gives -22. So 48 plus 22 minus 22, plus 22 minus 22 gets cancelled, and we get the valency of the fuel as 48. Now in this formula we have the required things. The molecular weight of oxidizer is given on the bottle, 375.13 grams. Molecular weight of the fuel, that is sugar, is 342.29 grams. Now we should consider the weight of the oxidizer for our requirement. Here I took the weight of the oxidizer, that is the weight of aluminum nitrate, as 1 gram. So if substituting this in the formula, weight of the fuel we should calculate. So the weight of the fuel is equals to weight of oxidizer, that is 1 gram, into molecular weight of the fuel, that is 342.29 grams, into valency of the oxidizer, that is 9, divided by 375.13. There is a molecular weight of oxidizer into valency of the fuel, that is 48. So after doing all the calculations we get 0.171 grams. To prepare aluminium oxide nanoparticles, we should take 1 gram of oxidizer, that is aluminium nitrate, and mix it well with the deionized water to prepare a solution, and 0.171 gram of fuel, that is sugar, and mix it well with the deionized water to prepare another solution. These two solutions are mixed in a beaker, and the beaker is placed on a magnetic stirrer for further mixing. The stirring is done for 15 minutes at 20 degrees Celsius. Now you can observe in this picture, this electrical balance is used to weigh the chemicals that we are using, that is aluminum nitrate and sugar, and this is the magnetic stirrer that is used to mix the solutions. And meanwhile, when we are mixing the solutions of aluminum nitrate and the sugar, the furnace should be set to a temperature of 500 degrees Celsius for synthesizing nanoparticles. Once the temperature of the furnace is set to 500 degrees Celsius, you can observe here the temperature of the furnace is set to 500 degrees Celsius. The number below shows the 500 degrees Celsius, and since we are stirring the solution, so it is raising to 895 degrees Celsius. We have to wait until the temperature reduces to 500 degrees Celsius, and then we can place our solution in this inside the furnace. So here we can place the beaker, and once the beaker is placed inside this, the combustion takes place. So after the sample of the solution is prepared, it is placed in the furnace for heating at 500 degrees Celsius until solution become free from water. Both oxidation reaction and reduction reaction takes place simultaneously. Liberation of heat and volume of gas takes place. It is an exothermic reaction. The liberation of large volume of gas prevents aggregation of the nanoparticles, and this whole process takes place within 10 to 15 minutes or less than this, depending on the water taken. If we take the quantity of deionized water more, then it takes a little bit more time to complete the combustion. If we take the quantity less, then within 10 or 15 minutes we can just synthesize the nanoparticles. And during this process, boiling of that solution takes place, frothing takes place, smoldering and flaming fumes are formed, and which will be very hot, and we can observe this the formation of nanoparticles by keeping this furnace open. And once the nanoparticles are formed, this will be very hot, and this has to be brought to room temperature by cooling naturally. And if we bring this beaker to the room temperature suddenly, then there is a chance of breaking of that beaker. So we take that beaker out and keep it for cooling naturally to the room temperature. After cooling the container, the material is collected from the container and mixed well using a mortar and pestle. Then here we can observe in this picture how aluminum nitrate solution is combusted and forms aluminum oxide powders, and this is collected in a mortar and pestle, and it is ground slowly. It is mixed well using a mortar and pestle. So this is done to get a homogeneous mixture of the particles. This should be done very carefully and slowly so that the nanoparticles formed, should not be damaged. Then this content is transferred to the crucible. Here you can observe the content is transferred to the crucible, and this crucible should be placed in the furnace. And when we are placing the furnace, the temperature of the furnace should be set to 950 degree Celsius. So here you can observe the temperature of the furnace is set to 950 degrees Celsius, and the crucible is placed in the furnace for calcination. So here you can observe the temperature of the furnace is set to 950 degrees Celsius, and the crucible is placed inside the furnace. Here you can observe in the figure, the crucible is placed inside the furnace for calcination. So here, during calcination, thermal decomposition, phase transition or removal of volatile fractions takes place. Calcination's process takes place normally at temperature below the melting point of the product materials. This calcination is done for 2 hours and the furnace is switched off. The material is allowed to cool as the temperature is very high, that is 950 degrees Celsius. It may take half a day or 12 to 15 hours to cool. And finally, the aluminum oxide nanoparticles are obtained. Further, this aluminum oxide nanoparticles are collected and they are sent for characterization for further studies. Hope this video helped you to understand about the solution combustion method. Thank you.